Know that your participation and engagement means the world to me, and it's so important for you. You will get more out of the class. You'll get more out of the material. But you also just add so much to the class. So I really appreciate you. And then always remember that these sessions are recorded and distributed for learning purposes. Today is July 9th. It is the middle of the week. It is hump day. We are halfway through the week, and just as importantly, this is officially halfway through the summer term. This is mid-term. This is the middle of our summer term. Last day is July 25th. So that means we have 12 more days. So it's going by really, really quickly. Okay. And same thing, we are exactly in the middle of Unit 3. Remember that Unit 3 is all about bonding. It's super short notes, super short unit. So yesterday we talked about chemical formulas and why things bond in order to become stable. Today we're going to talk about ionic bonds, and then we'll talk about covalent bonds tomorrow. Friday we'll talk about a couple other types of bonds, and then on Monday we'll have our exam. So we're going to review how to calculate charges on ions, and then explain how ionic bonds are formed, and how metals and nonmetals lose or gain valence electrons to become stable. And then we're going to introduce Lewis dot diagrams. Okay, so with that, I need you to open up our notes. Go to your calendar, or you can go to the announcements, and click on today's assignment, which is notes 3B, ionic bonds. Okay, so get those open. And we'll get started. Okay. Awesome. Thank you, Nia, Danny, Lamont Ryder. Thank you, thank you, thank you. Australia, Ayani, Ian, Jesus, Ahmad, Alex. I appreciate you. They'll say, Karina, ready? Princess, you ready? You good? Thank you, Michaela. Okay. Everybody good on finding your notes? Okay, let's do it. So, electrons, right? What kind of charge do they have? Are they positive or are they negatively charged? Let me know. Let me know in the chat. Are they positive or negatively charged? What do you think? These electrons that orbit the nucleus, they're negative. Thank you, thank you, thank you. Thank you, Australia and Yanni. I appreciate you. Yeah, they're negatively charged. So that means that if an atom gains electrons, okay, if it gains electrons, that means it's going to have less protons than electrons, okay? So it's going to have less positive charges and more negative charges. Then the overall atom is going to become negative, right? If a neutral atom loses electrons, though, then the protons are going to outnumber the electrons. And then we're going to have more positive charges than negative charges. And then that atom would become positively charged, right? So remember that these are called, any atom that's charged is called an ion, right? An ion. And we can calculate this charge on the element or on the atom by adding the positive proton charge to the negative electron charge, right? And remember, when we're adding positive and negative numbers, we subtract the numbers and keep the sign of the larger number, right? So here is a couple examples, right? So with this example, okay, I have an atom with an overall charge. It has 8 protons, right? So I'm going to have a positive 8, and it has 9 electrons. So notice that the negative sign is already there, right? So I'm going to put a 9 here. So 8 minus 9 is a 1, and then I keep the sign of the larger number, so that's going to be a negative 1, right? Easy peasy lemon squeezy. Now here is another example. Again, I have 8 protons. Okay, so I'm going to put 8 here. And this time, though, I have 7 electrons. So again, there's my negative sign. So here is my 7. 8 minus 7 is 1. This time I'm going to keep the sign of the positive number 8, which is larger than 7. Okay. Now, what is the identity of both of these ions? What is the identity? Do you remember how to do that? Remember, it's based off of the number of protons. So what are these atoms that are gaining and losing electrons? What type of element is it? If it had 8 protons, if it had 8 protons, tell me. Do you guys remember how to do that? Yeah, it is. It is oxygen. Yes, it is oxygen. And I know that, right? Because 8 protons, I look at that atomic number, right? So yeah, and that is the answers to questions 2, 3, and 4. 2, 3, and 4. Hey, Nia, glad you came back. Okay. Thank you, guys. Hey, Jesse, good to see you. Your timing is impeccable. We just got started. Thank you, Ahmed. Thank you, Australia. Ian, Jesus, Yanni, Jesse, Nia, Michaela, Danny, Lamont, Ryder. Thank you. Karina, Princess, you doing okay? Alex, Dulce, doing okay? Perfect. Amazing. Amazeballs. Okay. So that's questions 2, 3, and 4. Do remember that any atom that loses electrons and becomes more positive is called a cation. We remember that because the word cat has a T in it, and sometimes the T looks like a plus sign. And that reminds me that a cation is positive. Whereas atoms that gain electrons and become more negative, those are called anions. Anions. So I have a question for you to complete on your own. We have a ion that has 7 protons and 10 electrons. Okay, so the first thing you're going to do is calculate the charge. Remember, it is the charge of the protons plus the negative charge of the electrons, right? And so you're going to do the math right here to calculate the overall charge. Then you're going to tell me if this is a cation or an anion. Okay, remember cations is if this is a positive number. It's an anion if this is a negative number. Okay, and then based off the number of protons, you're going to tell me, is it nitrogen, oxygen, or fluorine? Okay. Danny, you good? I thought you clicked on it. Thank you, Nia. Thank you, Lamont Ryder. Thank you, Jesse, Australia, Yanni, Ahmed, Jesus. Thank you, thank you, thank you. Ian, you good? Alex, Dulce, Michaela, Princess, Karina. Awesome. You did click on it. Okay. I think we got it. Thank you, thank you, thank you, thank you. Awesome. Okay. Any questions on this question? You good? Okay. Let's go. So when we talk about ionic bonds, an ionic bond is just an attraction between a positive cation and a negative anion. It's not really a bond in that there's anything holding them together. It's just an attraction because opposites attract. Positive is attracted to the negative, okay? And the reason why this non-metal is going to give an electron to the metal is going to give an electron to the non-metal. And so that's going to become a cation, a positive ion, and it's going to be attracted to the non-metal. Both of them are going to be stable, but because of their charges, they're attracted to each other. Okay. Thank you, Yanni in Australia. Jesse, Jesus, thank you, thank you, thank you. Thank you, Nia, Michaela, Danny, Lamont, Ryder, Karina, Princess, you go, you two, okay? They'll say, Ian, ready, ready, ready. Thank you, Ahmed and Alex. Awesome. Good deal. Okay, no worries. You are good. I just want to make sure I'm not going too fast. So absolutely do not worry. Also, FYI, I've been told you can copy from my slide and then paste it directly into your notes. Just saying, especially if you have a big long word that you're not sure about the spelling, that copy and paste is kind of nice. Okay. Okay. So if I look at this, okay, here is a sodium, okay? And right now it's a neutral atom. Notice it has one valence electron, right? And this is a metal. Sodium is a metal, okay? Over here, I have chlorine, which is a nonmetal. It has 7 valence electrons, right? So if sodium gives chlorine this one valence electron, then sodium becomes stable because now it has 8 valence electrons in the lower shell. Notice instead of 3 shells, right? Now it only has 2 shells. And that lower shell is now full, right? Chlorine now is stable because it too now has 8 valence electrons, okay? And so what happens is sodium, when it loses that valence electron, right, it becomes a positive cation, right? Do you see the little plus right here? It's a cation. And the chlorine becomes a negative anion. And again, here's that little negative sign. And this makes sodium chloride, which is table salt. Okay, so this is question number 7. Thank you, Alex, Ahmad, Ayani, Australia, Jesus, Jesse. Thank you, thank you, thank you. Nia, Michaela, Danny, Lamont, Ryder. Thank you, thank you, thank you. Thank you, Ian. Perfect. Okay. Easy peasy lemon squeezy, right? So metals, remember metals are on the left side of the periodic table, right? And metals only have a few valence electrons. And so for them, metals lose electrons and become anions, okay? Nonmetals, though, they have a lot more valence electrons. They're in the upper right-hand corner of our periodic table. So for them, it's much easier to gain electrons. And that is, wait, I did this wrong. That is wrong. This means they become cations and nonmetals become anions. Wow. Wowza, wowza, wowza. And so it's metals and nonmetals that bond ionically. Okay. Metals and nonmetals bond ionically. So this is matching. Okay. And it's complete on your own. Remember, what is a positive ion called? What is a negative ion called? What is that bond when it's an attraction between oppositely charged ions? And which one has more electrons than protons? Remember, electrons are negative, so there's going to be more negative than positive charges. And then the last one is the opposite. Which one has more protons or more positively charged particles than negatively charged particles? Thank you, Yanni, Australia, Nia, Danny, Lamont, Ryder. Thank you, thank you, thank you. Thank you, Michaela. Thank you, Alex and Ian and Jesse. Hey, Jesus, you good? Thank you, Ahmed. Perfect. Awesome. We all good? Okay. So now, yay. Thank you, thank you, thank you. I appreciate you, Nia. That makes me smile. Okay. So here we go. Okay. Again, this is all about ionic bond. Here I've got magnesium, okay? And what these diagrams are, remember these diagrams are called Bohr diagrams. And Bohr diagrams show me the shells so that I can count valence electrons, right? So if I look at magnesium, which is a metal, there is 1, 2 valence electrons, right? Okay, there are 2 valence electrons, and it wants to lose both of those valence electrons. Okay, once it loses those electrons, then it has a positive charge and it becomes a cation. Okay. Oxygen over here, okay, oxygen is a nonmetal. It has 1, 2, 3, 4, 5, 6 valence electrons. It wants 8, okay? So 8 minus 6 tells me it needs 2 more to be stable. Once it gets 2 more electrons, then it's going to have a negative charge and it's going to become an anion. Okay. So then we're going to have an ionic bond between magnesium, notice the +2 charge, and oxygen that has a -2 charge. They cancel each other's charges out and are exactly what each other needs. Okay, so this is a ionic bond. Now, in your notes, you don't have to write the whole sentence. All you're doing is putting in the numbers. Okay, just put in the numbers. So magnesium wants to lose 2. Oxygen wants 2. Okay. Thank you, Danny, Michaela, Lamont, Ryder. Thank you, thank you, thank you. Thank you, Alex, Ahmad, Ayani, Australia, Ian, Jesus, Jesse. Thank you, thank you, thank you. Yeah, Ian, just put a 2. Exactly. Yep, yep, yep. Thank you, Nia. Okay. So question number 9, you're just going to put 2 in both of the boxes. Okay. Now, let's look at this one. Okay. Magnesium, we already did, right? Magnesium, we said in the last problem that there were 2 valence electrons. There's 1, there's 2, right? And so it wants to lose 2 electrons, and that makes it positive, and it's going to become a cation. Now, chlorine has 1, 2, 3, 4, 5, 6, 7. It has 7 valence electrons, right? How many more does it need? How many more does it need to get to 8? Tell me in the chat box. What is 8 minus 7? Right? 1. Yeah, 1. Okay. So this is going to be a negative charge, and that makes it an anion. Now, obviously, magnesium, right? Magnesium has 2 that it wants to give away, right? So chlorine can only take 1 of these electrons, okay? So we need another chlorine. We need another chlorine over here to take the other electron. So we're going to need another chlorine atom in order to take that extra ion. Okay, so this is question number 10. You can see magnesium gave chlorine, this chlorine atom, 1 atom or 1 electron, and it gave the other electron to the other chlorine atom. And now we have a molecule, we have a compound that has 3 atoms. It's got 1 magnesium and it has 2 chlorines, and they're all ionically bonded together because chlorine is negatively charged, which is attracted to the positively charged magnesium, and the positively charged magnesium is attracted to the negatively charged chlorine. Okay. So again, with question number 10, you're just going to type in the numbers. So this time you're going to type in a 2, a 1, and a 2. Thank you, Michaela, Danny, Lamont, Ryder. Thank you, thank you, thank you. Thank you, Yanni, Australia, Ian, Jesus, Jesse, Ahmed, Alex, you doing okay? Thank you, Nia. Dulce, you doing okay? Perfect. Okay, dokie. So that is question number 10. Now, let's look at this one, okay? Aluminum has 3 valence electrons, okay? I'm going to count them here just to make sure I did it right. So it has 1, 2, 3. It wants to lose 3. So it's going to have a positive charge and become a cation. Chlorine, we said in the last problem, has 7 valence electrons. It only needs 1 more, right? But aluminum has 3 electrons to give away. So how many total chlorine atoms are needed in order to make this bond work? If aluminum has 3 electrons to give away, but chlorine can only pick up 1 electron. How many chlorines do you think we need total? Yeah, exactly. It needs 3. It needs 3. And aluminum is going to give 1 electron to each one of the chlorines. Okay. And that's how ionic bonds work. Okay. So question 11, you're just going to write in one number. How many chlorine atoms are needed? Thank you, Alex, Yanni, Australia, Ian, Jesse, thank you, thank you, thank you. Michaela, Danny, Lamont, Ryder. Nia, you good? Jesus, Ahmad, ready, ready, ready? Yeah, perfect. Okay, so easy, right? Now, what we've been using are called Bohr diagrams, and Bohr diagrams show us a lot about the atomic structure. It shows us the nucleus in the middle. It shows us how many energy rings, electron rings that there are, and it shows us all of the electrons. A Lewis dot diagram is a little bit different. A Lewis dot diagram only shows valence electrons, okay? So in this picture that you've got right here, this is the Bohr diagram of oxygen. You can see the nucleus in the middle. You can see the lower energy shell that only holds 2 electrons. And then you can see that oxygen has 1, 2, 3, 4, 5, 6 valence electrons, right? In the Lewis dot diagram of a oxygen, all we have is the symbol of the element in the middle, and then we have the electrons around the symbol. And we put these electrons in pairs if there's pairs. And then single dots show us the unpaired electrons that are available to bond. Okay. So these are called unpaired electrons. And again, these are only the valence electrons. So the Lewis dot diagram doesn't help us really understand how a atom is made or what it looks like, but it does help us a lot understand what's available to bond. Remember that the only electrons that are involved with bonding are valence electrons. Okay, so that does help us a lot. Okay, thank you, Alex. Thank you, Ayani in Australia. Jesus, Nia, Michaela, Danny, Lamont, Ryder. Thank you, thank you, thank you. Okay, so again, only shows the valence electrons, which are represented by dots that are placed around the element symbol. Okay. Jesse, Ian, Ahmad, you good? Awesome. Okie dokie. So this is question 12. Now, Lewis dot diagrams do help us understand how reactive an element is going to be. Remember, if it has very, very few valence electron, it's going to be very, very reactive. Or if it's got like 7 and it's super close to being a full valence electron, okay? So it helps us understand the chemical reactivity of each element. And again, it shows us unpaired electrons that are available to bond, okay? Typically, electrons travel in pairs, okay? Now, they don't like traveling in pairs because they're both negative, so they kind of repel each other. So they're going to be single if they can be single, but if they're paired up, then they are not available to bond, okay? Thank you, Alex, Ayani, Australia, Ian, Jesus, Nia, Michaela, Ryder, Lamont, Danny, Karina. Thank you, thank you, thank you. Thank you, Jesse. Awesome. Perfect. Okay. So that's question 13. Thank you, Ahmed. Okay. So they are also great in showing and demonstrating bonds, right? We talked earlier about table salt and how sodium has 1 valence electron. Chlorine has 7 valence electrons. So if sodium gives chlorine this electron, sodium becomes positive, chlorine becomes negative, and then they're attracted to each other in an ionic bond, and it forms sodium chloride. So you can see this ionic bond. We can use Bohr diagrams and show these arrows, or we can do dot diagrams and again use arrows showing us where the electrons are going. Most chemists like to do the dot diagrams because they're also a lot easier to draw, okay? Instead of drawing all these circles and dots, they can just do the valence electrons, okay? So ionic compounds, okay, usually because it is a positive next to a negative, next to a positive, next to a negative, next to a positive, next to a negative, they form what we call crystals. Okay. And it's a crystal lattice that it's making. And it's a very, very structured organization to the molecules. And these substances have a very, very high melting point and a very, very high boiling point because these ionic bonds are super, super strong. A lot of energy is needed to break them apart. Okay. So this is question 14. And now it's only the first 2 blanks of question 14. I have to go to the next slide, next 2 slides for the others. So I'm getting there, I promise. Okay. Give me a thumbs up when you are done with the first 2 boxes. Okay. Yeah, that's what I like to see. Thank you, thank you, thank you, thank you. Thank you, Jesse in Australia and Ayani. Thank you, Nia, Michaela, Ryder, Lamont, Danny. I appreciate you. Perfect. Thank you, Jesus. Okay. Ian, you doing okay? Alex, Amon. So again, crystals and high are the 2 words you're going to use in those first 2 boxes. Okay. Okay. Then, okay, in the 3rd box, anytime a ionic crystal, an ionic compound is dissolved in water, it becomes a conductive liquid. It can conduct electricity. And these are called electrolytes. Okay. Now you've probably heard that word before, right? Like Gatorade is an electrolyte. Salt water is an electrolyte. Okay. And it's important for you to drink electrolytes when you exercise because your muscles and your nervous system is a electrical system. Believe it or not, it's an electrical system. And so the electrolytes help your muscles and help your nerves transmit their signals in your body. Okay. But when you sweat from exercise, you sweat out a lot of salt. And the salt is an ionic compound. And so you have to replenish it by drinking those electrolytes. Okay. So that's why when you exercise, it's important for you to replenish your electrolytes. Okay. Thank you, Yanni, Australia, Jesus, Nia, Michaela, Ryder, Lamont, Danny. Thank you, thank you, thank you. Thank you, Ian. Ahmad, you good? Thank you, Alex. Perfect. Karina, you doing okay? Yep. Okay. Last one on question 14. So ionic materials help become conductive because the ions can move, okay? And it can move when it's dissolved. And that's why electrolytes, when you have to drink them and it's in a liquid form, okay? In a solid form, it can't conduct electricity. So that word is right here, move. It has to be able, the ions have to be able to move. Okay. So that's the last part of question 14. Thank you, Yanni in Australia, Jesse, Jesus. Thank you, thank you, thank you. Michaela, Ryder, Lamont, Danny. Thank you, thank you, thank you. How's it going? Ahmad, Alex, Ian, Nia, Karina, you doing okay? Yeah, awesome. Perfect. Thank you, thank you, thank you. Okay, that brings us to our last questions, and hopefully you will be able to answer these 3 questions on your own. First question, which particles play the most active role in chemical bonding? Okay. Remember the dot diagrams, right? They show us which ones, the dots on the outside are the ones that we can bond. Ionic bonds are formed when electrons are destroyed, divided, shared, or transferred between ions. And then the last one, which elements in the periodic table? Is it metals and nonmetals? Metals and metalloids? Noble gases and metalloids? Noble gases and nonmetals. If you want to check your answer, you are more than welcome to private message me, and I will tell you if you are right or wrong. Okay? But those are our last 3 questions for today. Thank you, Danny and Lamont, Michaela, Ryder. Thank you, Jesse, Ian, Australia, Yanni. Thank you, thank you, thank you. Okay, I can go back. I will go back at the end of class, okay? And we will go back and pick up the ones that you need. Woohoo! Thank you, thank you, thank you, guys. Thank you, Ahmad, Alex, Yanni, Australia, Ian, Jesse. Thank you, Danny, Lamont, Michaela, Ryder. Hey, sis, you good? Yep, perfect. Okay, let me know. How are you feeling? If you are feeling pretty good, if you are feeling awesome, then you are going to be free to go. If you have questions or you need me to go back to a couple questions, let me know. I know that I'm going to go back to question 14 for sure, so no worries there.